Alright, so we're live? Cool. Alright, so, I guess let's get started, and I guess let's also mention a couple little notes that were brought to my attention over the last week. Um, so, I guess two things. I will start with the slightly less joking and not really as important one first. Technical issues last week. Loose
I
cable
feel
for the
that.
curious. Always make sure your stuff is plugged in all the way. The other thing that's actually a little bit more important was some people were expressing some concerns on the level of the class and the discussion material that was going on it. The class itself is
I'm gonna just come
very
chill
much,
beside you.
yeah, the class itself is very much
You're nice.
beginner level slash, assumes no existing knowledge, and when it's taught, that's what I'm going to be assuming. Um, but there are also some students who are going to know significantly more. Some may be professionals in the industry and the like. Um, this is also how it is in more formal settings and the like, when like such as university, you'll have individuals who have been programming since they were 12, and you'll have people who never touched a line of code until last week. So you're not really expected to know really anything when you start off like here. Here's an introductory course, and yeah, if you do want to talk about more advanced topics, by all means, feel free. I encourage it. It's interesting to see the diversity of skill sets and the like, but slash levels of experience, but don't be too intimidated by it. All right. I do see a comment here, so is sound amplifying on? Probably not, knowing me. How about now? Am I louder? I'm louder. Cool. Okay. I guess I'll go ahead and repeat the last bit, relatively quickly. Class itself is introductory. Some people are going to know a lot because they've been programming for years. Some have done it professionally. They're not expected to be at that skill level for the purpose of this class, but yeah, if you already are, feel free to discuss and the like at that topic and level. Just don't feel intimidated if you don't know what some of the other students are referring to on it, because that's just how settings go with computer science, because some people have been programming since they were 12, and some people touched it like a week ago or the day that they sat in the class. So that's just how it is. But yeah, don't be too intimidated by it. I had the exact same feeling many years ago. So, all right. So, um, getting started on the class. We're starting a little bit late this week. We're starting a little bit late today due to some technical issues on my side. I love VR. So this week we're going to be we're going to be discussing um, function IO and variables, and what exactly does this mean? So functions are, I guess the best way to phrase it is, it's how you group your code together, right? Like for example, on our last lesson, we used a function called print, right? And that was outputting the contents of whatever you pass to it to the console or slash to the user, you, so that way you could see what was contained in the program, right? I/O is broadly referred to as input output, and we're going to go more in detail on these throughout the lesson, but just for a high level, input output refers to the input of your program, the output result, right? The input might be some input from a user, like for example, their name, and the output might be the whatever is printed to the machine in. And my arm's gone flying. Brilliant. All right, well, I guess I'll use this one. And variables we briefly touched on this last week, but they you can view them as kind of containers and the like that will hold values in your program, right? So for example, x equals 3 is an example of a variable. All right. So with all that there, let's actually get started on the lesson. And of course, feel free to interrupt me at any point if there are questions, and I'll stop and answer them. These classes in general, when they're timed out, we assume that like roughly half of it's going to be questions in terms of time. So pure science, right? So today's topic, it's all about data, right? Um, so it's about Well, it's about input to your program, output to your program, right? It's how you store it. It's how you handle it. So yeah, today it's all about data, 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 data. All right. So variables and types, right? So we briefly touched on this, and I did kind of leave this as an open question yesterday. So not yesterday, last week. So last week, um, you may have seen 1.0, or on the challenge portion, you may have seen point something whatever, right? So that point something, or that value that was not a complete number, that had the decimal, that was a float, right? So an example of a type, right? You had your standard number and you had a float. So let's get a bit into context on variables, what they are, and we'll touch on the types a bit after that. So what is a variable here, right? So a variable, it's just an abstract to store a value, right? So it's done with an equals sign, and this is the case in Python and most programming languages. There are exceptions to the rule, obviously. Not every language is going to do an assignment with an equals. The vast majority will. But yeah, in general, assignment to a variable is done with the equals operator. And variables can also be assigned to each other. So for example, here we have a equals 1, and then we have b equals 2, okay? And we're going through here, and we're going to assign a value to c, right? Okay, so whatever the variable a is containing is now going to be assigned to the value of c, right? So in this case, right, we're going to be taking this value and assigning it to here. So I guess let's open this up to a question where I would like to answer. What can we expect C to output here? What can we expect it to print?
It'll just print A. It'll print 1.
Yep, yep, exactly. It's going to print the value of A, which in this case is 1. So, yeah. My full body is still glitching out, but it's better than yesterday, so we're going to go with it. I apologize if I end up looking like some unusual contortionist in a couple minutes. So, variable types, right? So, for a variable type, right? So, going through here as an example, right? All variables have a type. And Python's a little bit nice about this. It doesn't require you to explicitly define the type of the variable whenever you are defining it, right? So some languages will require you to define the type, right? In most cases, the type definition of those languages is going to be on the left side of the equals operator. In Python, they don't have to. So it's going to be inferred based on the value assigned to it, right? So for example, a equals 1. 1 is a whole number, therefore Python is going to assume is an integer. Okay. A equals high. Okay. So now we've assigned it a string. So it's going to assume it is a string. A equals 1.0. This is a float. Ints and floats, if you want the most abstract sense, an int is going to be a representation of your whole number. A float is going to be a representation of a decimal number. And I am sure there are some people who are either thinking in their head or commenting, yes, there are more data types than this. For the purpose of this course and in Python, we're going to keep this relatively simple on the number of types there are. But there are more than just this, and depending on what language you're in, you may find more. But for purposes of Python, here's what we got. And these are also fairly standard types that will exist in most languages you're working in. All right, so we also have A equals 1, 2, 3. Okay, and that is a list. Cool. So what does a list contain? Well, a list is a collection of objects, right? Or collection of primitives, if you want to phrase it a little differently, right? So, for example, in this case, it is actually containing integers, right? So in this case, it's containing 1, 2, and 3. So yeah, so The other fun thing with Python as well is the types are assumed, but they can be reassigned, right? So for example, in the example we have here, it's going to assume that it's an int, and then when we've changed the assignment, it's going to assume it's a string, and then it's going to assume it's a float. Cool. And I'm broken. Wonderful. Okay, well, whatever. All right, so let's go to the next slide, shall we? If my full body breaks too much, I'm just going to turn it off. As I'll turn off my full body. Okay. Okay, there we go. Had a weird networking issue on my side. Everything seems to be working now. So, more types. What's in a variable, right? Okay. So, we have a function called type we can use, right? And what type is going to do is it's going to give us the respective type we are currently using. If you're trying to think of what is a rational use case for this, you might use this if you want to do different handling based upon the type it's passed in. But let's use this to kind of show what this is going to be, right? So, for example, with a equals 1, right? This is going to print n. A equals I, this is going to print str. This is going to print float. This is going to print list, which, you know, for the most part, works about as you would expect. Okay. So, sometimes you have a type that is not the type you want to work with, right? So, on last week's worksheet, we wanted to print something as a string, right? Because we wanted to concat together two string values for the purposes of presenting them back to the user, right? So what we did in that situation is we did a cast, right? So we're going to talk a little bit about casting and the like on this, and show roughly how it works here. So you're also going to notice these are going to behave a little bit differently. So, for example, so for the first one, I have a equals 1, right? Okay. So if I add a plus a, I'm going to get 1 output. If I assign the value of a, or if I pass the value of a into a string function, which is going to convert it to a string, and then I assign that to b, and I do b plus b, which is I'm adding the strings, I should achieve a different result. So I guess I'll ask here, what does everyone think these two are going to output? Going to open this up to questions for everyone.
The first will output 2 and the second 11
Yep, you got
as
it.
strings.
Yep, you got it. String concatenation, it's not going to perform the arithmetic on it. It's just going to add the two values together. Which is slightly annoying if you don't realize the type that you received was a string and you've added them together and you expected them to do math, but hey, that's just how it works sometimes. All right, so gonna open this up to questions. Does anyone have any questions so far on where we are? And my tracking is all over the place, so I am just gonna turn it off at this point. Okay. So yeah, do we have any questions so far? Yeah, go for it.
Um, so for the last one, you
Hmm.
said it wouldn't do like regular math with it.
Correct,
It
yeah.
in my head it would come out to something like 4, but I just automatically went to math. So what does that mean?
So So what it's going to do is it's going to look at it and it's going to be like, oh, I see strings. Okay. What should be the operation when I do a plus, when I use a plus operator on strings, right? It's going to combine the strings together. So in this case, we have two ones, right? Which at the end of the day are a numerical value if we proceed to pass them into an int. But in this case, we've sent them to a string, right? So when we add them together, we're going to receive 1 and 1 as strings that have added together, which is going to show 11, which is extremely confusing if you're not expecting that to happen, right? So, like for example, if you were receiving some data from a user, right? Your user input is probably going to be a string, but if you're going to perform a arithmetic on it, you may unexpectedly be attempting to perform arithmetic on a string, which is not going to do what you want or expect. But yeah, does that answer your question?
I think so. Thank you.
Anytime. Do we have any more questions? Oh, go for
in
it.
this
Sorry, I cut you
example,
off.
that's okay. In this example, it's basically saying that a is the integer. It sees that as a number, but then we convert it to a string when we pass it over to b.
Exactly.
That's what
Yep,
the
nail
str.
right on the head.
Yeah.
Yep, nail right on the head. Exactly. So str in this case is the function we are calling that will convert that to a string, right? Are there very many use cases where you want to convert an integer to a string and then add them together? Probably not, but for the purposes of a example on what the behavior will do, it makes sense.
So in this particular case, if you wanted arithmetic out of it, you'd want to convert b back into integer.
Exactly. Nail right on the head.
Yeah.
Yeah, nail right on the head. Yep. But yeah. Good question. Yeah, that's what the goal of the example is to show the difference in the addition on the two different types. Okay, do we have any more questions?
At what skill level did you start using Git and GitHub?
I'm a bad example, and the reason I'm a bad example is I've been involved in the open source space since I was 14 or 16. So, what are we at? That would be, let's see, 29 years old now. So, yeah, a long time ago. For me, it was one of the first things I did because I was very much involved in open source, publicly available projects. So, in order to even pull down the code at that skill level, I had to understand how to use Git. Um, Personally, I found Git to be, at its most basic level, I find Git to not be too bad. I do find that once you get into more complex stuff like rebasing and squashing and trying to rewrite your commit history, that it can become a little bit more challenging. But in my experience, like it's usually a YouTube video, a tutorial crash course is usually enough to get started. But for me, it was one of the first things I was expected to know how to do. If I were to go more from the more traditional perspective on where most people are assumed, most people, if they're in a university setting, will be figuring out how to use it at some point during university, either their freshman or sophomore year. If they don't figure it out there, they will be learning it most likely at their first job because most companies use some degree of version control, and most of it is Git nowadays. There are exceptions. You know, Facebook is still uses Mercurial, and I think there's a couple companies that still use SVN, but yeah, it's a fairly introductory level skill to develop. Hopefully that answers your question.
Basically, yeah.
All right. That's also to say, if you don't know how to use Git, not a huge deal. It's something that you can genuinely learn in a couple hours with just memorizing a couple commands. People oftentimes make it a lot more complicated than it needs to. All right. Do we have any more questions, by the way? Either on the material so far or this lesson here? All right, I'm going to jump ahead a little bit further. Please stop me if anyone has any questions at any point. Okay, so I/O or input-output. Okay. So what's an example of an input here? So an example of an input. So there is a function you can use, right, in Python, which is just referred to as the input function, right? And this is going to request an input from the user. So our other CS professor, Apple, on here, we're going to use their name as an example in this. And so we have x equals input, right? Okay. So if we were to provide Apple for this, or we were to provide random, or we were to provide whatever, it's going to output this back to us. So on our print statement, we're going to go through here and we're going to print out this respective value, which is going to be hello Apple, or hello whatever we've set the value of x to be. So in the case of Python, all inputs from the input function are a string. And input is going to take the string input from the console. So the console in this case being when you run the program on something like Replit, you'll see a little window off to the side where your output on what the results are is being printed to. That is your console. If you want a more OS specific option, if you're on Windows and you open up something like a command prompt or a PowerShell, you can also kind of view that as your console. It is the output to the user for text. Or Linux and Mac with a terminal, one of the two, same concept. All right. So, do we have any questions on this? I see a hand. Go for it.
I'm sorry, my quest crashed while you were doing the questions for the previous slide. I didn't quite understand the B plus B print.
Oh, yeah, sure. We can go back through that real quick. That's not a big deal at all.
I'm sorry.
I am losing my... Oh, you're completely fine. These things happen. My tracking is breaking every couple minutes, so I completely understand how this tech sometimes is. So, all right. So, B plus B is a little weird, right? So, adding strings together, rather than perform math on the string, because B is a string, because we have cast it to a string with this function above here, with the str function. What that's going to do is we're going to attempt to add these strings together, right? So when you add strings together, or what it is oftentimes referred to as concatenating strings, right? So concatenating the strings is just going to put their two contents together. So because you have two strings that contain 1, what you're actually going to get is you're going to get 11 as a string, rather than with a plus a, where they are integers, where it's going to perform math and add it together and equal it 2. Does that make more sense?
I guess so. You lost me a little. I'm sorry.
Oh, you're fine. Where'd I lose you? Because if you're lost, there's probably
Uh,
someone else in the audience who is as well.
You said adding strings together and something about value of 2. That's all I got, really.
Okay, so when you add integers together, right, it's going to, as in when you add 1 plus 1, you would expect the value to equal 2, right? But if you're adding strings together, which is also known as concatenating the strings together, it's not going to do any math, so to speak, on it. What it's going to do is it's going to take, it's going to see internally, wow, that is terrible. but I can't write to save my life. Look at all this jitter. Okay, so what it's going to see is it's going to see 1 and 1 here. That is not what I want. Yeah, so what it's going to see is it's going to see 1 and 1, right? So what the string interpretation is going to be is it's going to be 11, which is I can't draw to save my life. Because what it's doing is it's taking a representation of it, right? So for example, if I had 2 strings that contained the word hi, and I added those together, then it's going to just say hi twice. So same
Oh, I get it.
concept as
I
that.
get it
Yep,
now. Okay. Thanks.
anytime. Star was also jotting out a example in a pen over there, which is going to be far more readable than what I am doing up here. I'm sorry, not to put you on the spot, Star. Yeah.
Helpful.
All right. Cool. All right. I'm gonna jump back a bit to the function part, not function part. Where were we? I'm gonna jump back a bit to the I/O portion where we were at. Does anyone have any questions on this so far? On where we're at on this? Am I losing my hand track? Oh, because I'm standing on the edge of my play space. Yeah, that would do it. All right. So next area we get to is functions, right? And a function, I guess, best way to phrase it is it's a set of instructions that can be repeatedly used, right? So you would use a function when you don't want to repeat yourself on the code. So, for example, print is a function. Print is the first function that we used in this course. It's a fairly common one, and it's what print will do is under the hood, it's going to take in whatever value you give it. It's going to perform a set of operations that will output that value to the console for the user, and the user is then able to see the output. So this is what is referred to as a built-in function, right? So this is already available out of the box, right? It may also be referred to as standard library, depending on the terminology that you're seeing. But this is a built-in one, right? You can also write your own, and in most cases, you're going to be writing your own. So, for example, so each function is going to have a few different parts, and I think this next one is actually an example of what a function looks like. Yep, okay. So I'm just going to jump ahead to this next one so we can go through the parts here as we're here. So what a function is going to have is going to have a name, it's going to have parameters, it's going to have a returned value, and it's going to have a function body. It might, and I want to add a couple notes on here, it might have a return type. In some languages that is required. In Python it's technically not, but we're showing it here for the purposes of the example. And you can technically have a function that doesn't return anything if you choose. It's referred to as a void function. Showing this for the example of trying to keep of brevity. Purposes of the example we're showing here, we're assuming that this function has a return type. But yeah, so in this case, add is the name of our function. Okay. And we're taking 2 parameters here. We're taking the parameter A, and we're taking the parameter B, right? And we've explicitly defined that these will be an integer type. If we try to pass in something that's not an integer, we will get an error, which is good. It'll tell us that we're calling it wrong and we're using our code unexpected. So it'll save us some trouble. We're also being told that this is going to return an integer, right? Okay. So that's what the return type here is the return type is the value that is going to be returned. This makes it a little bit easier when you're working with something to know exactly what to expect back. Like, for example, if you had a function that was named add and it returned a string, you probably want to know that before you go ahead and then perform some operation on the value otherwise, because it's not going to do what you expect in that scenario. And of course, we have the value that is actually returned. In this case, the return keyword, which is fairly general in most, if not all, programming languages. I would say most. You're going to have a keyword called return that is going to, well, define the value that is actually returned from the function. So here, for example, we're going to return the value of a plus b. And everything within this block below the function itself, we're referring to as the function body. As to how Python knows this is a function, it is searching for this keyword called def. In some functions, this may be func or function. In Python is def to define a function. So I just threw a lot at everyone here. So does anyone have any questions on any of this? All right, well, cool. It's awesome. If anyone does have any questions on this as we're going through here and we're actually applying
We
it,
have a
please.
question over here.
Oh, go for it.
So I was just entering the code on Python to see if it worked for me, and it said error, something about 2 dots at the end, and I was confused.
Error, exactly.
So, sorry. I entered in the code that you put up on the board.
Okay.
And it says def a int b 2 dots int. And then there's a little arrow right after the parenthesis, and it says syntax error expected 2 dots.
There's 2 dots at the end of this example. Yeah, right here.
So you have to type in int, or I thought it would just give it to you.
So what you can do if you wanted it to run is you could actually remove the return type and it will run. What it's expecting for on the colon at the end is it's expecting this to be the point where you define that this is the start of your function, if you will, right? So you've gone through and you've defined, here's the name, here are the parameters. Next line is where I expect to see the function internals.
Okay.
It's completely possible there's a typo in these slides, and if there is, by all means, please let me know and I'll get them updated.
I'm
it
someone who
doesn't
can
look like
easily point out
typo.
typos, if that would help.
All right.
Yeah, I don't see any typo in the code.
Okay. I do know last year when we taught this that there were a couple typos, and we've had to go back through and edit and revise those. So I know that code, like everything,
Okay,
sometimes when it gets
think I
copied
can
over, it has
see.
issues. Yeah. But yeah. Cool.
When you run the
Typos are
program,
awesome.
it's supposed to give you something.
Someone who's dyslexic that can easily point out typos.
No, as the method doesn't get as the function doesn't get called, it shouldn't print out anything.
Okay.
Correct. If it's not called, it won't output anything. That's correct. So in this case, we're just defining the function, and we're going to, yeah, if you wanted to call it, I think we have an example next slide that shows how to actually call this. Assuming this slide wants to run on my machine. We do have an example on the next one, but effectively, if you wanted to call it, it would be the function name and then the value pass in like this. So if you were to call add, you would pass in two numbers. Like for example, you would call add, and you'd pass in 2 and 5. 2 comma 5 within this block, and it should output, it would output, let's see, 2 plus 5 is 7, assuming I'm not too asleep today. Go for it, Star. Okay, cool.
Oh no, that was me giving you a thumbs up of that your maths is right.
Yay, I can do basic math. Excellent. All right. All right, cool. So that works. All right. So let me, I guess since I'm on the slide, I guess I'll continue with this, but if anyone has any questions, please feel free to comment, interject, and let me know what's going on. Oh yeah. So the fun thing is types aren't always needed. They're usually recommended that you have, just because it will make your code a lot easier to understand for the next person who sees it. And that next person is probably going to be you. It does make it a lot easier if you can be like, oh, I expect this to return this. But technically speaking, in Python, not required. Some languages is required. But yeah, showing it here for context because we are in Python. Returns aren't always needed as well. So for example, there is a function called a void function, right? And a void function is not going to return anything. So void functions are commonly going to be used for something like output to a user, right? Or actually, that's probably a really good example in the case of this course, is outputting content to a user, right? So like, for example, this is a very creepy message now that I'm reading it back, but I'm watching you type name, right? So what this is going to do is it's going to print this string back to the user. In this case, this function was called with name, which we gathered via an input from the user with what's your name. And we just put, and then we execute say hi name. And for the astute of you, yes, that is not the way you were supposed to name a function in Python. It's supposed to have an underscore between it, not say hi. But yeah, an example of one way this may be, a function may be named. Yep, exactly. Yep. Yep. You got it. All right. Any questions on this, though? All right. Gonna jump ahead real quick. Okay. So here's the add function being called. And so what we're doing here is we're calling, so this is to show an example, and I would advise not writing your code this way in an actual project, but this is to show passing a value from a function to another function to another function, right? So what this is going to do, this is going to do 3 plus 4, then it's going to add 2, then it's going to add 1, which means we're going to end up with a value of 10, and it's just passing in the previous value of add back into the function. Okay. Oh, I should probably get some context. The reason you don't usually want to write your code like this is fairly hard to track what's going on. So like, for example, we're doing this purely for the example of showing passing the output of one function to another. You can definitely, for example, take this value, assign this to a variable, and then pass it into the corresponding ones if you choose. And that would likely be cleaner, but purposes of showing us calling our own function and passing the values in, it's a good way to demonstrate it. All right. Do you have any questions so far on this? All right, excellent. Okay. So this week's workshop is going to be at the usual time, same time as last week, which is the event is currently in Discord. If I say it here, I'm just going to say the wrong time zone for a whole bunch of people, but it's currently posted up in Discord. But yeah. For this week's workshop, what we're going to do is we're just going to define a few functions. We're going to go through and utilize what we covered in this class, in this lecture. But yeah, does anyone have any questions on anything? Either from this material, last week's, or just in general? All right, cool. Well, I guess we're good to stop the stream, but it's a pleasure having everyone here. And have a good one, all y'all. Take care.
I'm gonna laugh because this is something I actually want to be a part of.